Welcome back, everyone. We are on to adding and subtracting rational expressions today, and this is one of the more difficult topics for people. So we're going to spread it out over 2 days, and we're going to break it down into the simplest form, and we'll get into a little bit more complex ones tomorrow. But for today, we're going to keep things pretty simple with our fraction rules. So you see the two fraction examples we have here, adding and subtracting of fractions. And in order to solve these, we all hopefully remember, in order to add and subtract fractions, you must have a common denominator. We need to be talking about the same value in order to be able to add and subtract. So, we're going to start with ones today that are all going to be simple denominators, where in order to find your common denominator, we're going to just stick with the rule that some of you use for all fractions, and you reduce at the end. But the rule that a lot of you learn is you can always multiply by the opposite denominator. So today we're going to make the problems work out so that you want to find the common denominator by simply multiplying both fractions by the opposite denominator. So let's attack these two fractions here. So on the left side, we recognize our denominators are 3 and 5. So in order to make a common denominator, I'm going to times both the top and bottom on the right side by 3 because of the 3 on the other side. And on the left side, I'm going to multiply both of those denominators by 5. And so by doing that, we've talked a lot about this with fractions. You can multiply the top and bottom by the same number because 5 over 5 is really 1. And when you multiply by 1, the value stays the same. So when we get 10/15, that's the same as 2/3. 3/5, we multiply that by 3 over 3, making it 9/15. And again, I apologize for my finger writing. It's not always the easiest to read. But we go ahead and make common denominators. The reason we do that is so that we can have things in common, that we can say, I have 10/15, I added 9 more 15ths, so now I have 19/15. All right, so that's reviewing of addition. Remember, subtraction works exactly the same, so we're going to cruise through this one pretty quick. The 4/7 and 1/2. In order to make a common denominator, we said for today, we're always going to be able to just multiply by the opposite denominator. We're not going to worry about reducing. We'll attack that tomorrow. So we go ahead and multiply by our opposite denominators, giving us 8/14 minus 7/14. And again, once they're a common denominator, now we can say they're both 14ths. 8 minus 7 is 1, so we end up with 1/14 for our answer. All right, this is the fraction world, and as we've shown the last couple of days, we practice with the fractions first so we remember the rules. Then we apply it to rational expressions. So here we go. In this example here, you recognize that I've put some algebra in here. I've added an x and added a y, and that simply makes it a rational expression. It's fractions with algebra, and we're going to subtract these. We're going to follow the same pattern all day today. Multiply by the opposite denominator in order to create a common denominator. So 4y is the denominator of the right side. So we're going to multiply the left side fraction by 4y on the top and bottom, making it 20y over 12xy. Because we have both x and a y in the problem, they're different variables, so we just write it as 12xy. You can multiply the 4 and the 3, but the x and the y can't go together. On the right side, I need to multiply by 3x, because that's going to give a common denominator of 12xy, which is our goal to make the bottoms the same. But we have to do the same thing on the top, so that we make sure we're multiplying by 1, and you end up with 6x on top. Now, this is where the rational expression part can in some ways be easier than doing this with just numbers. Because on top, you have 20y minus 6x. Well, those are not common terms. They don't have the same like terms. So therefore, I just leave it as 20y minus 6x. And when you subtract, with fractions, you combine them into one fraction by subtracting the tops and keeping the denominator the same. So this is a simple example of rational addition and subtraction. We just multiply by the opposite denominator. So now let's up the difficulty a little bit. This is a little bit of a higher level problem because you notice now we've made our denominators into binomials. You have x plus 3 and x plus 5. But we said today we're going to follow the rule that you can always just multiply by the opposite denominator because we know that will make something in common. So on this side, I need to multiply by x plus 5. I'm going to try to squeeze that in there. And on the right side, we're going to multiply by x plus 3. And again, our goal here is understanding the application of fraction rules to algebra. So we're going to do a couple things that are going to make your life easier. Number one, today we're making denominators work so that you simply multiply by the opposite one. We're not going to worry about reducing. But we're also going to say on the bottom, you can leave your answers in factored form because remember, the bottom of a fraction, when you add and subtract, all the bottoms do is stay the same. We're not going to do any work with them, so you can leave the bottom as x plus 5 times x plus 3 as the common factor for both. Now, on top, though, we do have to do some work because the top of the fractions are going to end up getting added together. So we have to distribute the 4 through the problem, making it 4x plus 20. And again, distributing is something you've been doing for years. It shouldn't be too much of an issue. We also have to distribute the 2x, giving us 2x squared, and 2x times 3 is 6x. So we've went ahead and changed our fractions into common denominators. It required us to do some algebra on the top. But our final step is to look at this now like a polynomial addition problem. On top, you have 4x plus 20 plus 2x squared plus 6x. We combine our like terms and we write our answer in descending order. So 2x squared, and then I have a 4x and a 6x. I can combine those to make 10x. And finally, the 20 has nothing to go with, so we get plus 20. And we said the whole way through, we can leave our denominators, our bottoms, in factored form. We'll multiply out the tops, but you can leave your bottoms in factored form. So our final answer is 2x squared plus 10x plus 20 all over x plus 5 times x plus 3. All right. We're going to look at one other example. It's not going to change the difficulty level, but it is going to bring up an issue that causes people trouble. So one more example and we're done for the day. Our third example shows us a common mistake that people are making on a regular basis when they do these problems. And that involves subtracting with binomials and trinomials. So this is going to be as difficult of a question as you'll see today. So in order to make our denominators the same, we're going to multiply this side by 2x minus 1. And we're going to multiply this side by x minus 3. So this problem is challenging on a few levels. The first level is it reviews multiplying binomials, where you have to do x times 2x is 2x squared. And then you're going to have a minus 1x and a plus 4x, making positive 3x. And finally, 2 times negative 1 is negative 2. On bottom, we said we can leave our answers in factored form on the bottom to save us a little bit of time. Now in the second fraction, 2x times x is 2x squared. I'm going to have 2 terms in the middle. It's going to be a negative 6x and a positive 5x. That makes negative 1x. And 5 times negative 3 is negative 15. And again, on bottom, we make our denominators the same. X minus 3 times 2x minus 1. All right, so we've created our subtraction problem, and it looks exactly like the addition ones we've done with a little bit of higher level algebra. But now comes the part where people make mistakes. When you subtract, we have to remember this acts like it's in parentheses. You're subtracting the entire fraction. So you do 2x squared minus 2x squared. Those cancel each other out. Then you have 3x minus negative 1x. That chops into a plus 1, making 4x. Finally, negative 2 minus negative 15. That chops into a negative 2 plus 15, making positive 13. So our final answer is 4x plus 13 over x minus 3 times 2x minus 1. And you can see where there's a lot of chances to screw up here. You have to be able to do polynomial multiplication and polynomial subtraction. So there's a lot of chances to screw up, but this is something we can all do. So this is a little bit of a longer video. I apologize for that. Tomorrow we're going to attack a couple of the more difficult situations with addition and subtraction. So good luck, and we'll talk to you again tomorrow.